Hey class, welcome back to the unit on surface area. We're going to get into the last lesson, which will take a couple of videos, and we're going to talk about surface area for pyramids and cones this time. And we're going to see the difference between pyramids and prisms and cones and cylinders and how that plays out for surface area. So in this particular lesson, we're going to discuss the nets of pyramids and cones, how those are comprised, how we can find the surface area and lateral area of each. So let's jump right in. Might take a couple of videos, but let's see how far I can get. Now, notes. Let's talk about some cool things in regards to pyramids. So this is what you will find with a pyramid. Such thing as a square pyramid, such thing as a hexagonal pyramid, such thing as all sorts of pyramids. But the point about a pyramid is that they come to a singular vertex. They have a base with a singular vertex. That's what makes a pyramid. Now, with a pyramid comes something different that we haven't dealt with in prisms, and that is something called the slant height. The slant height is a new thing. Okay, and the slant height goes from the vertex of the pyramid down to one side of the base. Okay, so a base edge, if you will. And so we have to understand what the slant height is and how it differs from the height. Okay, how it differs from the height. So the height goes from the vertex straight down, perpendicular to the center of the base. The slant height goes from the vertex to the base edge. Okay, so that is a huge difference, and slant height is the key. Okay, so when we approach the net, when we see the net of, in this case, a square pyramid, make sure you see the difference between the height and the slant height. The slant height would be found as the height of one of the triangles that make up a lateral face. Okay, so make sure you see the difference. Okay. Now, of course, the area of this particular triangle is half base times height. Still the same thing. 1/2 base times height. 1/2 the length of the side times the slant height. Okay, so it's still areas of triangles are still 1/2 base times height. So we see what's going on with the pyramid. Now let's dig into some surface area and lateral area notes. So we got to remember what's happening with a pyramid. We have a base and a singular vertex from all of the lateral faces. And the lateral area of a pyramid is 1/2, here's that lowercase p again, the perimeter of the base. So make sure we recall that the p is still perimeter of the base, times, instead of the height like it was in the prism, it's the slant height, or cursive lowercase l. Okay, the cursive lowercase l for slant height. Okay, so we see in our diagram we have our slant height. Slant height is the key. Seeing the slant height is the key. Visualizing the slant height is the key, because that will give us the lateral area. That means the area around the pyramid. Okay, so lateral area, 1/2 perimeter times slant height. The surface area of a pyramid. Now remember, a pyramid has a singular vertex. Okay, so the surface area of the pyramid is the lateral area plus only one of the area of the bases. Okay, so if you have not seen the previous two videos, don't bother with this. Stop, go see those, come back here. And so what we're going to do now is compare our formulas between the prism and the pyramid. Okay, the prism we have locked up, we're good to go. If you remember, the lateral area was the perimeter of the base times the height. Well, for a pyramid, the lateral area is half that. Half the perimeter of the base times the slant height, in this case, slant height. In the prism, the surface area was the lateral area plus 2 times the area of the base. In the pyramid, the surface area is the lateral area plus only 1 of the area of the base. Okay, so it's very similar to the surface areas we have worked with before. And again, when in doubt, folks, just make your areas, draw a net, find your areas, good old segment addition postulate. Let's get busy. Let's do it. Let's do some examples. So here's our first example. We're going to find the surface area of this hexagonal pyramid. And the question, of course, begins with, how do we find surface area of a pyramid? And the surface area of a pyramid is the lateral area plus the area of the base. So when we look at our figure, we can see that we have a hexagon base. That will become problematic momentarily. But in the meantime, let's first find lateral area. And how is it that we find lateral area? Remember, lateral area is 1/2 the perimeter base times the slant height. Now, what you may not know is that in this particular example, our slant height is given. Remember what the slant height is. The slant height goes from vertex to the base edge. So from vertex to base edge is given to us. The slant height is 9 inches. That's super helpful. So we already have the slant height of 9 inches. All we're missing now is the perimeter of the base. Now our base is a hexagon, as said in the directions. Each side of the hexagon is 6 inches, so our perimeter of the base should be easy to derive. 6 sides times 6 inches will result in a perimeter of the base, which is 36 inches. So our lateral area is going to be 1/2 of the perimeter of the base, which is 36, times the slant height, which is 9. And the rest is calculator work. And so we find out that our lateral area is 162 square inches. Okay, we're still working in square inches because we're still working in area. So we're finding the surface area. We have found the lateral area. All we're missing is the area of the base. And so here's where we must do some review from Chapter 10. Chapter 10 review. Now, we're finding the area of the base. The base is a hexagon. So let's remember that. And how do we find the area of any regular polygon? The area is found by multiplying 1/2 the apothem times the perimeter. So we must use the apothem, and we must find the perimeter. Now the cool thing is we've already found the perimeter. It's 36 inches. So what's the deal with the apothem? Now hopefully you remember. If not, take a quick trip down memory lane. In the pop-out triangle of regular polygons, remember the old pop-out triangle, we have our radius is the hypotenuse. The opposite leg from the half vertex angle is the half side. And the adjacent leg to the half of the vertex angle is the apothem. Okay, so we have to remember that from our previous unit. Now, in order to find the area of the base, we're multiplying 1/2 the apothem times the perimeter. What we need is the apothem. So when we look at our given diagram, guess what we know? The apothem is right here, and the apothem is given to us as 3 times the square root of 3. So fortunately, the apothem is given to us, which means that the area of the base is doable to find. 1/2 the apothem times the perimeter. Okay, so that would give us the area of the base. And so we do some calculator work here. We end up with 54 times the square root of 3. How's that happen? Here's how it happens, right? So I have 2 going into 36 as 18. So it's 3 times the square root of 3 times 18. Now, in this case, I'm going to leave the square root of 3 as if it were an x. 3 times 18 is 54. And so we have 54 times the square root of 3. There is my area of the base. So we are ready for surface area then, right? It's the lateral area plus the area of the base. Lateral area, 162. Area of the base, 54 times the square root of 3 square inches. So all we have to do for surface area is add the 2. And from here, it all depends on how the question is being phrased. Are we keeping it in simplified radical form, which is what we're doing here? Are we rounding? Is it asking about? The rest is calculator work. And so how do we work this in the calculator? Now, since we're doing addition and multiplication, we have to be careful with how the calculator works. Okay, now I said multiplication here. Make sure you remember that. That is 54 times the square root of 3. Because we're multiplying and adding, I'm going to multiply first. 54 times the square root of 3 equals, okay, so that's what that is. I'm going to add to it 162, and I will have my resulting surface area. So it all depends on the question, right? So it could be 255.53 square inches. It could be 255.5 square inches, or it could be 256 square inches. It all depends on how the question is being asked. In this case, it doesn't specify, so either one of these should be good. Okay, and that's how surface area of a pyramid works. Let's dig deeper, shall we? Yes, Mr. Katz, let's do that. Okay. The pyramid of Cestius is located in Rome, Italy. Using the dimensions in the figure below, what is the lateral area of the pyramid of Cestius? We're going to round to the nearest square meter. So here in this case, we're using lateral area. And how is it that we find lateral area of a pyramid? It is 1/2 the perimeter of the base times the slant height. Now, here's what's interesting. When we look at our diagram and we use the figures that we have, the question becomes, do we know the slant height? Or can we find the perimeter? The slant height is not given to us. We don't know. So what we have to understand originally is that 36.4 is not the slant height. Okay, we have to yell at you for that. That is the altitude of the pyramid. That is the altitude of the pyramid. That is not the slant height. Remember, the slant height goes from vertex to the base edge. So that's not it. Okay, so we have to recall that. And then we move on from there. If that's not the slant height, how are we going to find it? Well, take a look at what we have in this another pop-out triangle. We have 36.4 is given. Now, in that particular triangle, what would be the length of this particular leg? It's not going to be 30. It's going to be half of 30, which is 15. Okay, so we have to understand that what's given in the figure, this is not all the way 30. That leg is half of 30, which is 15. And now we can find our slant height. How, you may ask? Well, Pythagoras has an answer for you. Remember good old Pythagoras? Okay, so he can say, well, my theorem should help. Why, yes, it can. So we would have 36.4 squared plus 15 squared would give us the square of the slant height. That means if we were to find the slant height itself would be the square root of 36 plus 4 squared plus 15 squared. I'm not going to use calculator yet. Why? Why am I not punching this in my calculator? Because we're going to round at the end. I am not going to perform that operation right now. I'm going to round at the end. So we have found our slant height. Whatever number this is our slant height. Okay, so make sure you're comfortable with that. The other thing that we needed to find was the perimeter of the base, the lowercase perimeter. Each edge is 30. There are 4 of them. Our perimeter is 120 square meters. Okay, so we now know our perimeter. We now know our lateral, our slant height. We can now find lateral area. Okay, my fourth period is on their way here, but we can wait. So our lateral area is 1/2 the perimeter of the base times the slant height. Now remember the slant height. I didn't crunch that number yet, and there's a reason. Because the rest is calculator work. Now how is this going to work? Let me teach you how to use the calculator. How is this going to work? We will have this number first. So we'll do 36.4 squared plus 15 squared equals that. And then we take the square root of it. Square root. And that's what it is. We're going to multiply that by 120. And then we're going to divide that by 2. So all of that calculator work. And we have a beautiful number. But we are instructed to round to the nearest square meter. So this nearest square meter means I'm rounding to the nearest whole number. So our lateral area is in fact 2,362 square meters. Okay, so we have to pay attention to rounding. And that is how surface area and lateral area works for pyramids. So come back to the next video. We'll start talking about cones. But hopefully you learned some stuff, and I'll see you in the next video.